International Show. My name is Jane and I'm part of the strategy team here at ZeroAvia. And this afternoon I would like to talk to you about zero-emission routes and the potential for zero-emission regional aviation travel. So I'm going to first quickly introduce ZeroAvia and our first two products, and then talk more broadly about the opportunity for regional air mobility. So a quick introduction to ZeroAvia. We are producing hydrogen electric engines for aircraft. We are focusing on hydrogen electric because we believe it's the most economically viable, scalable and truly zero-emission solution to aviation. We take a step-by-step approach to our development, proving the technology works at each stage, and this has led us to where we currently are with our first product, the ZA600. This is a 600 kilowatt powertrain designed for aircraft such as the Cessna Caravan, which is going to be on launch, the Twin Otter and the Dornier 228, which is actually our test aircraft in our facility in the Cotswolds, and you can see the videos of the test flights on our reel. This is designed for the 9 to 19 seat aircraft and will be available from 2026. We're simultaneously working on the key technologies for our second product, the ZA2000. This is a 2 megawatt plus powertrain designed for the regional turboprop market, such as ATR 72s and Dash 8s. So longer term, the work for both of these products is providing key learnings, IP and technology for us to scale to the larger aircraft. And some of my colleagues have been talking about how we can get this technology all the way up to narrow-body aircrafts. But what I want to focus on today is the first two products and the impact that they can have on aviation very soon. So starting with our first, the ZA600. So we'll be targeting 250 nautical miles. And as I said, first application is the Cessna Caravan. 98% of Cessna Caravans that flew in the last 12 months flew less than 250 nautical miles, and therefore, in theory, could be retrofitted with one of our engines immediately and be a zero-emission flight. These missions happen all over the world, quite a lot in North America, primarily cargo routes, but also in Africa and Asia. 25,000 tons of CO2 were produced by these flights in the last 12 months, and so in theory, they could all be eliminated with the introduction of our technology. When you look more widely at the whole sub-regional market, 96% are less than 250 nautical miles. That equates to about 290,000 flights, and it is a very global picture then. We're looking again across North America, but into South America, Europe, and more across Africa and Asia. And again, these represent quite a large amount of CO2 emissions, 128,000 tons, which could be eliminated with a hydrogen electric powertrain. So then looking at the ZA2000, our initial design will target 500 nautical miles, and I'm going to use the ATR 72 as an example. 95% of the operations on an ATR 72 in the last 12 months were less than 500 nautical miles. This is over 1 million flights, and the dots start to get a bit kind of closer together now on the maps, but this is across Europe, South America, more Africa, quite a large presence in India, and across the Southeast Asia and the Pacific. Altogether, this is nearly 2 million tons of CO2, which could be avoided with hydrogen electric aviation. And then more widely across the whole 2000 market, I mean, you know the formula by now, 90% of them are on these shorter routes. It's 2.6 million flights, and again, these are a lot of real routes with a lot of people, a lot of cargo being transported across the globe, producing a lot of CO2, all of which can be addressed with hydrogen electric very soon. So that is what is currently being operated in the world at the moment, but I want to talk a little bit more now about the potential for the growth of regional air travel more generally in the future. In the United States in particular, regional air travel has a rich history. In the 40s, the Federal Aviation Act paved the way for construction of almost 6,000 airports. And there was a real vision that air travel would be the way that would connect the American population. And the idea was that the average American would only be 16 minutes from an airport. In the 70s, the deregulation allowed the expansion of routes and more competition upon routes, and what happened with that alongside the development of larger and larger aircraft was the consolidation of the aviation industry into large planes on specific routes between large hubs. This has led to the cheaper and more affordable air travel that we all enjoy today, but has left lots of airports around the US underutilised, and the regional air travel a smaller industry perhaps than had originally been envisaged. Now, we believe that hydrogen electric can be the enabler to revive this part of the market. The reason for this, first of all, is the cost. So the reason that operators moved to large aircraft was because it was more economically viable. Hydrogen electric is going to be lower cost for operators due to lower maintenance costs as well as lower fuel costs. So this could reduce one of the barriers for operators to operating regional aircraft. The other is the lack of emissions and the lower noise. So one of these barriers to short-haul flights, understandably one of the criticisms for short-haul flying, is the emissions and the increased noise and low pollution for the local population. Hydrogen electric can reduce both of these barriers and enable local airports to operate more. And the benefits can be really, really great. So one of them is connectivity. This is particularly important in areas in, let's say, the US or the UK, for regions that are very poorly served by rail and road. Air can really offer an opportunity to bring that connectivity. It can be a boost to the local economy, not just for jobs at the airport itself, but also just allowing people to travel more across the country. And then also in certain areas, it can be really important for providing vital services, such as medical or humanitarian aid, which can all be done zero emission. So I wanted to just bring this to life with one example that's particularly pertinent to us at ZeroAvia. We have two sites in the UK, one in Cotswolds Airport and one in Sandwich in Kent, of which the nearest airport is Manston. So I can tell you from personal experience, it's an absolute nightmare travelling between these two sites. If you want to stick purely to public transport, it will take you over 6 hours. If you travel by car or taxi the side of the train, then you're looking at 3.5 roughly. But if we could fly between these two, we're talking just over an hour. This kind of travel would be absolutely transformative for us as a business, and I'm sure there would be many benefits that people in Kent and the Cotswolds would enjoy as well. If you draw a 250 nautical mile radius around the Manston Airport, that includes Paris. So I'm sure many people there would enjoy being able to pop over to Paris for a weekend. So just to conclude, one of the questions that we get asked the most is, the technology seems promising, but how far away is it? The point that I'm going to make is the future of clean flight is a lot sooner than we think. There are millions of routes around the world carrying people, carrying cargo that can be addressed by our products very, very soon. And there's a huge opportunity to grow regional air more generally with our technology. Thank you.